So, we've all seen AI do some pretty mind-blowing stuff, right? But what if I told you that most of it is basically just a super high-tech parrot? Today, we're going to look at a breakthrough method that helps an AI stop just mimicking us and start actually thinking by teaching itself from scratch.
And yeah, this is the real question, isn't it? I mean, we can dump endless amounts of data into an AI, but how do we get it to build the actual scaffolding of logic all on its own? It's a huge puzzle, so let's dive in and see how they cracked it.
Now, to really get why this new method is such a game changer, we first have to talk about the big problem that's been hiding in plain sight. You see, AI is absolutely brilliant at one thing, but that brilliance has been masking a really fundamental flaw.
And this right here is the critical distinction. Modern large language models, they're conversational wizards. They can write you a poem, they can write code, pretty much anything you ask. But they're a lot more like brilliant parrots than actual thinkers. The moment you ask them to solve a problem that needs a logical, step-by-step chain of thought, well, that's when they often just fall apart.
Okay, so how did we used to try and fix this? Well, think of it as two kind of flawed approaches. Method one was the brute force attack. You manually create these gigantic hand-labeled data sets. It's incredibly slow, it's super expensive, it's a huge pain. Method two was more like the wishful thinking approach. You just show the AI a few examples and kind of hope it figures it out. It's faster, for sure, but the results were often wildly inaccurate.
And this is where the big idea completely flips the script. What if the AI could write its own textbook, learning as it went? That's the entire idea behind this incredible method called the self-taught reasoner, or STAR for short.
The secret sauce to this whole thing is one simple word: rationale. And it is exactly what it sounds like. You remember in math class when your teacher would always say, "Show your work"? Well, a rationale is just that for an AI. It's the AI laying out its step-by-step logic to get to an answer. And believe me, this simple idea changes everything.
So here's how that learning loop actually works. It's this beautiful, elegant four-step cycle. The AI tries to solve a bunch of problems, and then it acts as its own tough teacher. It only keeps the logic, the rationales that led to a correct answer, and it throws out all the rest. Then it retrains itself using only its own success stories. And after that, it just repeats the process, getting a little bit smarter every single time. And this is where the magic really kicks in. The authors call it a synergistic process. A better way to think about it is like a snowball rolling downhill. The better the AI gets at reasoning, the better its own training data becomes. And of course, that better data then turns it into an even better reasoner. It's literally a self-improving engine.
Okay, but hold on a second. You might be thinking, there's a potential problem here, right? This loop is awesome for getting better at stuff the AI already kind of gets. But what happens when it hits a wall? When it's just completely, totally wrong? How does it learn then?
I mean, this is the million-dollar question, right? If the AI is only learning from its successes, how does it ever break through a tough learning plateau? Are all of those failed attempts just wasted energy? Or is there some way to actually learn from those mistakes too?
And this, I think, is the most clever part of this entire method. For all the problems the AI got wrong, the researchers used a trick they call rationalization, and it is brilliant. They basically gave the AI the answer key and said, "Okay, you know the final destination. Now, draw me the map that explains how you get there."
And think about how powerful that is. By reverse engineering the solution, the AI creates a perfect custom-made lesson plan for the exact problems that were stumping it. It's like shining a giant spotlight on its own blind spot so it can finally learn the logic it was missing.
All right, so this all sounds great in theory, this clever loop of generating and filtering and rationalizing, but does it actually work in the real world? Well, the results are, honestly, they're pretty staggering.
So first off, let's just talk about efficiency. The researchers put their STAR model up against the gigantic GPT-3. Now, you can think of parameters as sort of like the number of knobs in an AI's brain. The STAR model had 6 billion of them. GPT-3, 175 billion. That means the STAR model was an incredible 30 times smaller.
Okay, so it's way smaller, but how did it do? This is the jaw-dropping part. On a really tough common-sense reasoning test, the massive GPT-3 scored 73%. That tiny little STAR model, it scored 72.5%. That is virtually identical performance from a model that is 30 times smaller. This isn't just an improvement, it's a revolution in efficiency.
And if you want to see just how much of a difference the method makes, check this out.
Using the exact same base model, standard prompting, is basically a coin flip. It's only right about 36% of the time. Even with fancy tuning, it hits a ceiling at 60%. But the STAR method, with its self-taught logic, launches that score all the way past 72%. That, right there, is the power of learning how to reason instead of just memorizing patterns.
So, let's zoom out. What does all of this actually mean? Why should you care about a smarter training method like STAR, and what it means for the future of artificial intelligence?
So what's the bottom line here? Well, this whole thing points to a future where really powerful AI isn't just for a few giant corporations. It means we can have smaller, cheaper, more accessible models that can actually think, not just match patterns. It's one of the first real steps towards an AI that can truly learn on its own, tackling bigger and bigger problems without us having to hold its hand the whole way.
And the researchers themselves put it perfectly. They're clear. This isn't just one clever trick for one type of problem. They believe this core idea of using simple examples to bootstrap complex reasoning is a fundamental approach that could unlock the entire next generation of self-improving AI.
Which, of course, leaves us with a pretty fascinating, almost philosophical question. As we build these systems that don't just learn what we teach them, but learn how to teach themselves, what's the first problem you think we should ask them to solve? What challenge would you give an AI that can truly, actually think?